Hello students, this is your Class Connect recording for lesson 5.03. I'm in the course content and today is lesson 5.03, which is the Unit 5 worksheet. We actually covered the content in the textbook yesterday, but we're going to do the worksheet now. You go into Unit 5 and the first thing you need to do is download the periodic table from the top of the unit. Once that's open, you can go to lesson 5.03 and notice that the worksheet is in the assessment. It's in the 503 assessment. There's the Unit 5 worksheet. Open that worksheet. When it's open, it will look like this, and your periodic table should look something like this. We do need it. Okay, so on the periodic table, the first thing you need to do, of course, is read all the directions. These are the goals. These are the things that we should be learning from this worksheet. Now, these are the directions, the things you need to actually do. Number one, do not change the formatting on the document. If you change the formatting, I don't know if I'll be able to grade it because it'll be very difficult to find the information. So do not change the formatting. Number two, it starts on page 2 and make sure you go all the way to the end. There are 10 total, okay? You need to open your document for the periodic table and you need to fill in each field on the table below. For each item, you are going to do the symbol, the group, and the common properties, which the common properties should come from the actual textbook that's in your lesson, and we'll look at that a little bit. The period and the number of orbitals, the number of valence electrons, you're going to make a Lewis dot diagram, and my suggestion is to do the Lewis dot diagram in the program Paint. All right, you should have down in your start menu, if you go to the search menu and you type Paint, it should come up. And then you hit enter and it will open. Once Paint is open, that's a really great program to use to draw in. You may do this entire thing in Word, but if drawing in Word is difficult, you can print and do it paper and pencil. Make sure that your pictures or your scans are legible. If it's too dark or too out of focus or at too much of an angle, like if you're taking a picture with a camera, if I can't read it, you're gonna have to take a new picture. So be careful about that, but I don't really care. You can do it in Word or you can do it paper and pencil and submit a picture file. That's okay. However is the easiest for you to do it is okay. I did add slides in lesson 502 and 503. Those slides will help you. I do recommend that you open them. It's the CC slides in the Learn part of the lesson, and also, of course, in the Textbook Explorer. All right. I'm also giving you a hint that the first orbital in the Bohr model, if you're drawing a Bohr model of the atom, the maximum number of electrons, I shouldn't put a valence electrons, but the maximum number of electrons the first orbital can hold is 2. The maximum number of electrons, not valence electrons, but electrons in general, that the second orbital can hold is 8. The maximum number of total electrons, not just valence electrons, but total electrons in the third orbital is 18. And the maximum number of electrons, not just valence electrons, but electrons total, in the fourth orbital is 32. If you get to three orbitals, 4 orbitals, and where you've got 18 or 32, not all of those are actually considered valence electrons. Even if they're in the outside orbital, make sure you get your number of valence electrons the way we learned in class. Okay, let's actually look at this. I did an example for you, and the example is selenium. So let's find out where we got these answers, and then I'll help you do hydrogen, and the rest of them you are on your own. So first thing we need to do is find selenium on the periodic table. So we look at the periodic table and we go down here, and it's actually number 34. I'm going to zoom in so you can see it a little bit more clearly. And selenium right here is number 34. And remember, when you're looking at the periodic table, the whole number is the atomic number, and that is the number of protons. The number with the decimal is the atomic number, and that is the total number of protons and neutrons. And we will round it when we need to find the number of neutrons. And 78.97, if we round it to a whole number, would be rounded to 79. So now that we know what selenium is, let's see what we can answer on our document. I'm going to move this over so we can see selenium in the document at the same time. So the symbol for selenium is capital S, lowercase e, and in this case, capitals and lower cases are very important. The period number, remember we've got periods and groups. The periods are the column numbers, and if you look, selenium is in column number 16. So the period number is, the group number. The groups are the columns. The column number is 16. That's the group number, and that's where that 16 comes from. It's in group 16. The period is the row. So when you count the rows, the helium and the hydrogen is row 1. That's period 1. This one is row 2, or period 2. This one is row 3, or period 3. And then selenium is actually in the 4th row, or the 4th period. And so that is where that period 4 comes from. From this information, we should be able to answer a whole lot of questions. How many orbitals does selenium have? And when we talked in class, we know that the first row has 1 orbital with 1 or 2 electrons. The second row, or the second period, has 2 orbitals, 3 orbitals, 4 orbitals. So if it has 4 periods, it has 4 orbitals. That's very important when we come to draw the Bohr model. The group number tells us the number of valence electrons. So if we look at the group number on here, okay, we know group 1 has 1 valence electron. Group 2 has 2 valence electrons. We talked about skipping the low ones because they're more complicated, but we come back up to group 13, has 3 valence electrons, 4 valence electrons, 5, 6, 7, 8. Selenium is in group 16, so it has 6 valence electrons, and that's where I get the 6 from. The group name actually came from the lesson 5.03, page 8. So if you go into lesson 5.03, Learn, the textbook Explorer, and you go to page 8, it will tell you that group name. So as this page loads, we'll go all the way to page 8. There we go. And you can see that we have groups 16 and 17. And it tells us they only need 1 or 2 valence electrons to complete their outer shell, meaning they've got 6 or 7 in there, right? The elements in group 16 are in the chalcogen family, meaning ore. These are ores, like when you go into mines and they're mining for ores. These are some of the ores they might mine for. And then group 17 is the halogen family, and they are salt formers because when the group 17 combines with groups 1 or 2, they form salts. That's why. All right. So we can go back onto our document here, and we can say, okay, it's the chalcogen family. How many bonds can this atom make? Well, we know it has 16 valence electrons. We also know that 8 is the most stable. 8 being the most stable minus 6, which is what it has, leaves space for 2 bonds, and that's where that 2 came from. Do they tend to lose, gain, or share? Well, if you look at your periodic table and remember what we've learned about it, we know that selenium is one of those non-metals, and that non-metals in general will either take electrons from metals, groups 1 and 2 metals, or they will share electrons with other non-metals. And that's why it says share or gain. Properties. What kinds of properties does it have? Well, again, that came from page 8 in the lesson. So you can go on to page 8 and you can read a little bit about what they do and remember some of the things about metals versus non-metals, and selenium is a non-metal. And that's where the information came from. So things that I wrote down on our document here is that they bond with highly reactive metals. They produce salts and ores, and they only need 2 electrons to complete the outer shell. So it's really just kind of a description. So then I'm ready to do the Lewis dot diagram. And remember, I gave you the key so you know how to put the dots on. The X represents the symbol, and we know the symbol for selenium is capital S, lowercase e, and that there are 6 valence electrons, and they have to go on in a certain order. 1, 2, 3, 4, 5, 6. So there's 1, 2, 3, 4, 5, 6. And I did that in the program Paint. I chose the typing tool, I put it up there, and I did my capital S, lowercase e, and then I chose my circle tool. I gave it a fill color. So this is the line color, and then this one is the fill color. And then I put the dots. 1, 2, 3, 4. Notice these are opposites. This one's left, this one's right. This one's top, this one's bottom. See that? 5, 6. And then with no fill, you don't have to put these extra ones, but whoops, not that one. There we go. Notice with no fill, the extra 2 spots for bonds are the 2 empty dots. You don't have to put the 2 empty dots in there. I didn't ask for them, but that's how I know that there's 2 extra bonds, because there's 2 spots that are not filled. So now what I want to do is I want to take a picture of it. So I use my snipping tool. I can type in snipping tool in my search menu. There it is. Hit enter. It will open. When it opens, you can just click new, take a picture of it. Once you have your picture, you can copy, go on to your Word document, and right click and paste, and it'll go in there, and then you can shrink to fit. All right, I'll take that out since I've already got one in there, right? Notice I didn't ask for the empty bonds. Then I got the Bohr model, and we've done this in class a lot. So the first thing I did in Paint is I put in my protons, which are 34. That matches the atomic number on selenium. And then I took my atomic mass, which was the 79. 79 minus 34 is how I got my neutrons of 46. I know that there are 4 orbitals, so I drew 1, 2, 3, 4 circles, and then I started filling in the electrons. And that's where this comes in handy, right? I know 2 of the 34 fit in the first circle, 8 of the 34 in the second circle, 18 of the 34 in the third circle, and then whatever's left over goes in that outside circle, and there are my 6, 1, 2, 3, 4, 5, 6 valence electrons. All right. Once that's done, then you're ready to go on to the next one. So I did a hard example so you can see where it all comes from. Next, you can do hydrogen, and hydrogen is up here on the periodic table. And notice hydrogen is an easy one with 1 proton, no neutrons, 1 minus 1 is 0, and it's in the first one, so 1 valence electron, so it's 1 proton and 1 electron and 1 orbital. right? 1, 1, and 1. So that should be an easy one to do. If you have questions or need more help, you can call me or email. Have a great day.